Okay, so let's talk about end behaviors. And so end behaviors of a function is what happens at the very ends. So it's at the very ends of the graph, and you want to know basically whether it's increasing forever, or if it's decreasing forever, or the other way, if it's increasing forever, or if it's decreasing forever. So that's what you want to know about these end behaviors. So let's say I've been given this function over here, and I want to know what it does as x approaches infinity. So as I go this way, what happens with my y's? Do they go up or do they go down forever and ever and ever? So what you do is you take a really, really, really big number and you plug it in for x and see if it would be positive or if it would be negative. So a really, really, really big number that I could think of would be 1,000. So I'm going to plug 1,000 in. And again, I just can pick whatever number I want. So it could be 1,000, it could be 2,000, whatever number that I want to pick. But it's got to be really big. Like, that's the key. If you put 1,000 into there, you get 1,000 cubed, which is really, really, really big positive. And then that really, really big positive times 3 is going to make it more positive. So this thing becomes a really big positive number. And so that means it approaches positive infinity. That's what it does. This is the sign for infinity, if you didn't know. So it approaches positive infinity. Let's see what happens when we throw a negative in there. So I'm going to do the same thing, negative 1,000. Negative 1,000 cubed becomes a really, really, really big negative number. And then a really, really big negative number times 3 will give you a really, really big negative number. So as x goes this other way, the first time it went up, as x goes this way, it's going to go down. So what you do is you're going to put a really big positive number in, you're going to put a really big negative number in, and you're going to see which way it goes. Let's do another example. So example number 2, let's say this is my function this time, which would be 2x squared plus 10x plus 5. Well, we're going to do the same thing for our end behaviors. We're going to see what's going to happen when we go this way, what's going to happen when we keep going this way. Well, if I put a really big number, this is going to have the most impact. Like, the leading term is going to have more impact than all this other stuff. So I actually don't have to really worry about this other stuff, because when you get in the millions and billions, this becomes so much larger than everything else that you stop caring about these terms right here. So this is the term that I care about, and we're going to see what happens when we throw really big numbers into here. So when I throw a really big number, a really big positive number into here, well, a positive number squared becomes a bigger positive number, and then that positive number times 2 becomes a bigger positive number, so this goes to positive infinity. As I go the other way, I'll throw a negative number in here. Well, a negative number squared becomes a really big positive number. And then a positive number times 2 becomes more positive. So this one approaches positive infinity. So these end behavior things, you plug in a really big positive number, you plug in a really big negative number, then you kind of see what happens. Okay, so the next part about this is graphing these things. Now, something like this, I'm not going to be able to graph by hand. Like, we learned yesterday how to graph stuff by hand, but today we can't do that. So we're going to use a graphing calculator. Which we're going to use Desmos. But a couple of these things, like a relative max. Let's say we have a function that kind of does this. If you have a function that does this, it doesn't have an absolute max, because if you ask what its biggest point is, well, its biggest point keeps increasing forever. And if you ask what its smallest point is, that keeps decreasing forever. But you do have this kind of loop shape that gives you a max, which would be that point right here. That's what we would have as our relative max. It's the biggest point relative to the rest of the graph, because we kind of get this looping shape. Now our relative min is the thing that kind of loops the other way. So our relative min is the thing that kind of loops down. So if you remember from quadratics, this looping up motion like this was what we called our maxes. And this looping down motion was what we called mins. So your min is this point, and it's always your y value. And your x is this point, and again, your max is this point, and it's always your y value. So we're going to find those in a graph, because we're going to graph that on Desmos. And then your y-intercept is going to be what your y-intercept is always. Your y-intercept is going to be where this graph crosses the y-axis. So let's see what this graph looks like when we graph it in Desmos. And as you can see, with this graph, we get kind of that shape. Now we're going to find the points that we care about. Our max looks to be right here. So our max for this thing would be 5. If we go back, our min looks to be this point right here. And if you look, it's again the y value. So it looks like it's about -11. Our y-intercept is where it crosses the y-axis, which for us is our same point as our max. So that would be 5 again. Okay. So what you really want to do is you want to go through and find those different things. Relative max is going to be that thing in red. It's the topmost part. Your bottommost part is going to be your relative min, and this thing where it crosses the y-axis is going to be your y-intercept. Just try to round to the nearest whole number if you don't get a whole number like we didn't for this point, and that's what we want to do. Thanks.